Okay, going live on Instagram. We're live on YouTube and Facebook. Are we live on Instagram? Alright, welcome back to another episode of Shoot the Chips with I2R CNC. This is Sunny again. I got Pat to my right and Joel to my left. We're just going to wait for the Instagram to go live. Give it another 10 seconds. Okay, we are now live on Instagram. Today we're just going to do a quick basic cover of the type of bits that you can use with the machine. So we have 3 different lines of machinery models. We have the B series, which is our first entry level. That's going to have your 1 horsepower and 2 horsepower spindle options. And then moving up to the A series, that's going to have your 3 horsepower spindle option. And then as well as the W series, which is your 4x2, also going up to a 3 horsepower. The executives are all 3 horsepowers as well. Now, the main difference here when you're talking about bits is the size of the shank and what's holding it. So we have the ER11s, the ER16s, and the ER20s. So each one's
What's on the exec?
The exec is the ER25 if you're going with the Italian spindle.
Right.
Okay, so
what size shank can that go up to? 3/4?
Half inch.
That's gonna use half inch also.
Oh, really?
Yeah.
Okay, weird.
So going back to the ER11 when we start, that's gonna be with your 1 horsepower, right? So we've got 1/4 inch bits with the shank here, for example, like this one. It might be kind of hard to see on live, kind of far away. But Instagram, here's your standard compression bit, and this one's gonna be a 1/4 inch shank, and then we've got. Do we have 1/8 inch? No, we don't.
Yeah, we do.
Where?
We have an 1/8 inch shank right here.
There we go.
Or an 1/8 inch blade right there.
So we're sticking on shanks. So here's 1/8 inch, and then moving up to your 3/8 inch, which we would use on our 2 horsepower for the B series. This one is your ball nose. It's got your standard upcut, and it's got some coating here too. And then on your 1/2 inch shanks, you've got this compression bit, which you would typically use on the 3 horsepower naturally, and that's gonna be your ER20, ER25, like Pat was asking about. So kicking it to you guys for your projects, when you're looking at the different type of bits, the tool manufacturer is going to be the one that's going to have the material that specific bit type would be cutting, and then also you can use it for general speeds and feeds. But when it comes to speeds and feeds, we have our own guide that we provide. Some of them are going to be a little bit too fast on our spindles. For us, we use a high-speed spindle, and they're all going to go from 0 to 24,000 RPM. And your RPM is going to vary depending on what material you're cutting, how fast, how deep, and also the size of the tooling. So earlier when I was saying 1/8 inch shank, and Pat was saying 1/8 inch on the actual cutter, what he was talking about, the difference here is you have the shank size that will fit into your cullet, but then when you're actually cutting, this one is going to be a 1/4 inch shank, but it's got an 1/8 inch diameter on the cutter. So this one's a ball nose. Typically, if you're using your 1/8 inch, that's going to be better geared toward smaller jobs, like if you're trying to do high detail work with engraving. If you're going to use your 1/4 inch or your 1/2 inch, even 3/8, those are better for doing your pocket tool paths. Pocket tool paths meaning you're hollowing out, carving away, and removing, ejecting material from your workpiece. Your 1/2 inch and your 3/8 inch is going to be the most efficient in terms of saving your cutting time when you're trying to reduce that amount. So if you were to imagine trying to use a 1/4 inch bit, trying to remove material versus a 1/2 inch, you could see a big difference in just the amount of material removal. Okay. If we want to talk about types of material and what type of bits you want to use, one of these guys can tell you about the projects and which go-to bits they specifically like to use. The ones we have here are just your most standard that you would use on a day-to-day basis. You have your engraving, your pocketing, and your profiling, and also your surfacing bits here. So let's talk about, what should we start with? 3D projects?
Yeah, you
Sure.
can start with 3D projects with the table ball nose.
Alright, so let's move this to Pat, and let's Pat. What's up, Pat?
Hello. Also to everyone else. Can I see this?
Yeah. Let's talk about your 3D work.
So essentially with 3D, almost every 3D project is going to have a roughing pass and then a finishing pass. It can have multiple roughing or even multiple finishing passes. It's really going to depend on the scale of the project or the detail that you want to get out of it. So the reason you might want to do multiple finishing passes, which I've done in the past and it's actually worked out really well, is you want a smooth contour on 3D models, typically, unless you're trying to do some weird thing. But if you're working on, I don't know, a 2 foot by 1 foot thing, you're not going to want to use this tapered ball nose, which only is a 1/16 of an inch at the tip, because that's just going to take forever. But what you can do is use something like this for your first finishing pass, which is a 3/8 inch ball nose. So while you're not going to get fine details, if you're trying to do lettering or any kind of features, like let's say you're carving a face, you're trying to get real fine details on the eyes or something, this isn't going to do that for you. But something that's really nice about Vectric is that when you make a finishing pass with these 2 bits as your setting, it's going to specify that this bit is essentially just getting the big contours, and this bit's going to come in and only do those fine detail sections. And you can actually set how detailed you want your model to be. Because more or less the model is always going to be, and I mean the digital 3D model is always going to be more detailed than what comes off your machine, just because with 3D meshes you can get super, super fine details. So you never need to go 100% detailed. But using a larger ball nose with a smaller tapered ball nose is definitely the go-to. With that said, if you're doing a smaller project that you can just bang out in one pass with a tapered ball nose, this bit is, I would say, my favorite bit. I don't like to pick favorites, but this is the SC64 by Whiteside. It's a 16th inch tip tapered ball nose. I believe 16th inch radius. Yeah. So it's really that can't be right, because is this a 1/8 diameter?
No, that one's the smaller one. I think that's the 1 in 32. The one
Yeah,
you're
so
talking
this is a
about
1/16
the
inch.
1/16. That's the That's the 8th inch.
SC65.
Yeah.
This is this is
66
the
or 60.
16th inch diameter
Yeah.
too. But this one, almost every 3D project I've done, I've used the SC64. Also a free plug for Whiteside, so you're welcome. But most 16th inch diameter tapered ball noses will get you the same results.
Yeah, I mean,
I just don't know why I
the
really like the
Amana one's also
SC64.
pretty good too.
Amana's good.
Yeah, but I think that one's got a better punch for the value
Yeah.
in terms of pricing. Yeah.
So there's a brief summary of tapered ball noses.
So there's one we don't usually use a lot. The nose cone right there. This one's got the.
I
this
actually
one's
just
got
used
a-
that one.
Yeah, that's why I pointed it out. So that
Yeah.
one's got the 1/4 inch shank, but actually on the cutter it's 1/2 inch.
Yeah. Which I will say, if you have the option, you're much better off going with this one, which is the same diameter of a ball nose. So it's the same cutting diameter, but it has a 1/2 inch shank. So it's just a lot more sturdy, and you don't have to worry about the machine. With this one, I actually got some stutter, and it actually stopped the machine. Another issue was just the cut direction, but when I went in and did the same toolpath on a different piece of material with the same makeup, with this, it was a lot cleaner, a lot smoother, and a lot better machine sound. So by and large, if you can, as in if your collet will support it, you're better off going with a shank size that's closer to the cutting size than trying to press a 1/4 inch shank to cut at a 1/2 inch diameter. Yeah, it's just a lot more sturdy.
Okay, so that one you're usually dealing with wood and MDF.
Yeah.
Right? That's what you're using mostly. Now that previous one, the conical ball nose, also mostly for wood. I have used those to cut plastic because they are rated for that too. We've done that with brass as well for 3D engraving work. So those bits do work pretty well, but they will dull a lot faster.
Yeah. Do a very shallow cut.
Yeah, the ones
depth,
with
too.
speed tool work.
So if we're talking about cutting aluminum, we've got some great aluminum bits here too. My favorite one is typically the O flute, but then we also have a great one with the end mill with the helix.
Here, you want to
spiral.
take over?
So, yeah. So just to do a quick general, we've got
Real quick, hey,
here.
what's up? PC Works, how you doing? You said what's up in the comments.
Alright.
Sorry to cut you off.
Yeah, no worries. So main difference between these two is you got an 1/8 inch cutter here, and then this one's gonna be a 1/4 inch. This one is a bits and bits. They've got that coating that they have there for added protection with heating, and also will help you with the wear and tear. This one is a generic O flute, but these work great because they kind of, if you look at it from this perspective, have a crescent moon, and that one spiral there will help you eject the material as it's being removed. Very, very clean. Either one, depending on your projects, your size, and is going to depend on what you want to cut. The other one that I like to use here for aluminum is your spiral helix here. You can see this one's got 3 flutes and a very short cutter length because you don't want, the shorter it is, the more stable it's going to be, less deflection, less chatter as the bit is moving along and trying to cut the material. So when you're dealing with harder materials like aluminum, shorter is better. So this bit is great, gives you a very clean surface finish. Alright, so the next one that we're moving on to, going back on why it's shorter. So for example, like a bit like this, even if this was capable of cutting aluminum, this is not something I would recommend because it's so long. You're going to have a lot of chatter and noise as it's cutting, trying to remove that aluminum.
Yeah, I don't like that bit.
Yeah,
Even
especially with
Also,
that one,
this
you could
is
just break it,
this is
just
a
shatter
ball.
halfway.
Yeah.
This one is a monobit, so you don't want them. Just kidding.
I mean, it's good. It's good if you're like cutting super
Yeah.
deep, I guess. But
Also, yeah, this is great for when you're trying to get into those, 3D projects, remove that excess.
it's
But-
just the chatter and the screech from it. Like it's unsettling. I don't like it.
Compression bits. These are going to be great for plunging deep into the material and removing wood. You can go very fast with these, and it's got a combined down cut and an up cut force, and leaves a very clean mark. But if you are going very aggressive with this too, it also does leave a very loud noise.
Well, it can.
It can. Yeah.
Actually, I've noticed on the A series,
Mhm.
if you're using a 3/4 inch compression, it's like silent. It's
Is it?
crazy. Yeah, it's
Okay.
super nice.
I'll let Joel talk about V-bits and also the surfacing. Maybe talk about considerations on when you're spoiling the MDF. That would be a helpful one. I think people want to know.
So I know a lot of times when you get your machine, the first thing that you want to do is especially surface it because necessarily it's not going to be leveled. I've got a lot of people mentioning about surfacing. So one thing I'll take into consideration is that in V-carve, you don't just have a surfacing bit. So you'll just have to use an end mill, and then after you'll just increase the diameter of it. So that way it'll be like, let's say for instance, on this case, a 1.5. So that way when you're doing the diameter, it's going to take over the parts that you have specifically for the dimensions of it. And our recommendation usually, I would say when we're using the B series, we'll want to go with a faster spindles RPM, which is 24,000, which is the max. And then afterwards, I would say as for the consideration with the 1 horsepower and 2 horsepower, I would stay within 1,000. I would say relatively 1,200.
What, for feed?
Oh yeah, for the feed.
Yeah.
And then afterwards, as far as the feed for, I would say for the 2 horsepower, you could push it up to 2,000.
Easily,
Yeah.
Also depends on your cut depth. Or if it's
yeah.
MDF, like you can tear through MDF. It's nice.
Especially if you want to go slower with the feed, I would say on the 2 horsepower, you'll notice that it's going to take a lot of time.
Yeah, exactly.
Yeah, you want to take the best consideration of doing both.
Yeah.
And another thing as well, like you were mentioning, how deep you want to go. So it's dependent on the type of diameter that you're using for your surfacing bit.
Mm-hmm.
You don't want to just stress it out. And just like what we're seeing with the compression bit, especially with the 3/8, if you start using it, you could also use it as a surfacing bit.
Mm-hmm.
But the only issue is, I would say, if you plunge too deep and you're not taking into consideration, like usually I would say the general rule of thumb that they'll say is half the dimensions of the diameter. But if you push it way too much, you could risk shattering a bit.
Well, and compression bits are weird because they can handle a lot. Because for the first pass, you have to be. So could I see that compression bit real quick? So the reason I like compression bits so much, and they're actually kind of genius in their design, is so if you don't know, like if you've ever seen a video of a CNC thing, or I mean, when I was starting out, I was doing this all the time, so you can find it in our earlier videos. But essentially, when you're doing an upcut, there's an upward force on the surface of your material, so that results in tear out. So you get really kind of frayed edges. That's why when you're doing a surface engraving, you want to use a down cut, which would be this. So as it turns, you can kind of see it's keeping a downward force where it's pushing down on the surface, so it's not tearing out any of the grain. The only issue with that is that it can trap dust in your in the pocket and actually be recutting that dust, heating up the entire operation, and could wear your bit a lot worse. Also, when it cuts through to the other side, that downward force is now blowing out the back of your material, so it could actually ruin the surface on the back. That's why compression bits are amazing, because when you set your first pass depth to be lower than the upcut section, or to have the upcut section fully submerged in the material, what's cutting your surface is this downcut section, which is keeping a downward pressure. The upcut section is evacuating chips, and when you cut all the way through, that upcut section is going to be pushing up on the bottom of your material. It's going to maintain that surface finish for you. So, genius solution. Whoever, I don't know who invented this, but they're onto something with this one. I like compression bits a lot.
Yeah, instead of just using the down cut, which, like you were mentioning, it's just recutting the same dust.
Okay. So you've got the surfacing bit here. Talk about the step over on how people can get a cleaner shave on their MDF boards.
So usually with that, what I recommend is that you could also lower the step over. So a lot of times I would say people want to go 40 or 50, but if you lower the step over, the percentage wise, you'll allow it so that way once it's moving relatively, it's cutting each of the portions of the material. As far as the compression bits, like I was mentioning before, they both cut and do similar activities. Where I would say, if let's say for instance, if you're doing epoxy and then after you're surfacing it, instead of just going with a surfacing bit, you could also just go with an end mill and just go with one like a 3/8 or a 1/2 inch, and it'll do the same thing. But you'll just take into consideration the time it's gonna take.
Yeah, well, and it's kind of the double whammy of like, in a 3/8 inch compression is going to be a smaller diameter, but you can cut a lot deeper each pass. So, like, I was just working on something that was only a 2-inch diameter circle and did epoxy, had to clear it, and like the obvious choice was to go with a end mill, just because cut deeper and it fits. So that's the other thing.
Yeah, one thing that you should know about these surfacing bits is the blades need to be swapped out over time.
Those blades specifically need to be swapped out.
It's so dull.
just know that over time, these do need to be swapped, and you could even flip them on just by using these two screws, loosening and tightening. We have a bunch of blades. We just never used it on this one, but I'm looking at it now, and yeah, it's time to change it.
It's past time.
So another thing for that, and then you've got one on your 1/2 inch, which we've been using a lot for the A series. Um, Obviously, with a larger spindle, you're able to drive that bit a lot harder. But at the end of the day, it's not just the spindle power, it's also going to be related to what it's connected to, right? And that's going to be the frame, the gantry, the ball screws, the linear rails. They all work together like the foundation of a building. So if that's not properly built, no matter how strong or great your spindle is, you're not going to get a clean cut either. You're going to be trying to push your machine a lot faster, but then you're going to have a lot of vibration and chatter with that larger bit. So make sure you have a spindle with a great bit that's connected to a system that's designed to work together as one cohesive unit so that you have the best performance. And when you're talking about entry-level machines, the B series is great for that because you have a very well-built system. Even though the spindle sounds like it's just a 1 horsepower, that spindle is very powerful, and the only limitation there would be the size of the bit, which is why we have the 2 horsepower option, and then also with the A you have the 3 horsepower. V-bits. Let's talk about V-bits. This one we've got 1/4 shank also, and I don't think we really I don't personally use this bit that much.
That one either.
I think Pat's used it a little bit, but for the most part we're using 90 degree, 60 degree, and then we've got the bit set for the white side engraving. That one's really good because it gives you all different angles from 45 to 60, 90, has your pencil points.
Big shout out to 30-degree angle V-bits.
Yeah.
Those are great.
Yeah. So what are you using this in terms mostly? You're using a V-carve toolpath, right?
Yeah.
And you're doing this for, I'd say, getting those V on your signs.
Yeah, especially for lettering.
Your letters.
Sharp
Yeah.
corners.
And the sharp corners, or if you're trying to do inlays, you would go with a V-bit.
If you can figure it out.
And you could do a chamfer too
Yep.
with this style, which has more flutes. This one's got 3. You can even do a chamfer on aluminum. So depending on which one you're using, generally speaking, for all the woodworking type things, lettering that we're talking about, you're going to want to use a bit similar to this one, either a 60 or 90 degrees. So if you look very closely, you probably won't see it on the camera. One way, if you can't eyeball the different degree of the V-bit, on here you'll see a little A, and that tells you the degree of the pitch of your blades there. So look for that on your Amanas specifically. They're very good at that if you want to distinguish your degrees of bits. Okay. Anything else that we didn't cover?
They're similar to the V-bits. They're engraving bits, but I don't know if they're here. But the only difference, it's for details.
Which one?
That's why I was referring to that one.
This one?
Yeah, the engraving bits.
Okay.
It's like that. It's just
It's
shallower
similar.
angles.
Yeah.
Flat heads, pencil points.
Okay.
It's pretty skinnier V-bits pretty much.
Yeah.
Finer detail.
Yeah, I think we've covered, for the most part, everyday bits that we use. If you need, for example, like this one, anything finer, we do have bits that are the 1 millimeter in radius, and then we also have the white side ones that Pat likes. Those are the 1/8 inch, and then 1/32, and then also the Spectra coated Amana. They're all great bits, just depending on what you want to spend. I really do like all of them, and we have them on our website. So if anyone needs more bits, feel free to reach out to us. We'll definitely hook you up. Call us. We've got some discounts going on right now on the bits, so if you want, we have the inlay bit set also is one that we actually didn't mention, but that's great for inlay work, and there's different strategies on that, which I think we can probably release some content on, different strategies for doing the inlays. Stay tuned for that. But other than that, I think we're good on time now. Any questions? Let's see who's got some comments. Goop Master. Is this machine user-friendly to beginners, or would you have to know any specific knowledge? Great question. So for the most part, you're not going to really need to know something like Joel here. You're not going to need to be like an engineer, or if you're not a very handy person, you just at least...
Put the camera on you.
I'm just talking to selfie. So
Joel looking off into the distance while you're talking.
So you know, hold this for me.
Sure.
So we lost the tripod for that phone, which is why we gotta use the hands. But you don't really need too much knowledge as long as you know how to use a computer, you know. And then secondly, I would say as long as you have a passion for making and woodworking or anything that entails creative work. I would say woodworking, we have a lot of guys who have been working with their hands. They have their own shop that they've been making signs. They've been making any type of project you can think of with hand saws, miter saws, things like that. And they just want to add automation to their hobby. So what they'll do is they'll come into CNC. And what's great is because we've got these packages where we support you. We can log right onto your machine and show you by clicking around your computer where you need to go, how to navigate, and overall use the machine. I think we've got people who've never touched a CNC before, and they're brand new to woodworking, and we have them up and running on day one when they receive their machine. The reason we are able to do that is because of our software. So the UC CNC software is not only great because of the 3D graphic user interface that shows you live time tracking and position of where your bit is in relation to your graphic design and where it's cutting on the machine, but also it allows us to log right on, connect to your PC because it's all integrated. You can connect to the internet, connect to the cloud where all your files are saved, and we have an application where Joel, myself, one of the team guys will log right onto your computer and give you a 3-hour training session, one-on-one, dedicated to you on how to use the design software and the machine. We've had 70-year-old retirees who didn't even know how to use email, and we basically teach them how to use email first. And once we get that out of the way, we log right onto the computer, do all the installation for them, and then we get them on making their first design with the machine. So that was kind of a long answer to answer a question that you put, but it's a very valid question. It's a great question. So the answer is no, you don't need to know everything. For me, when I first got into this, I didn't know anything about designing. I didn't know anything about woodworking. I didn't know anything about the machine. It was all self-taught, and I had a lot of help from my partners too, that are out there over in, shout out to Stony CNC over in Ireland. They were instrumental in helping us get started when we first launched our CNC projects. So yeah, if you have any other questions, hit us up. We can answer them. Joel can help you out with that too. Any other comments down there that we didn't get to? That was Goop.
No.
That was Goop, right? Goop,
Thanks, Goop.
Goop Master.
Goop
Alright, so
Master.
make sure we take down Goop Master, and then we'll DM him and send him a free gift too or something. All right.
Cool.
Thanks, guys.
Sorry to
Thanks for another
neglect you as always.
Yeah.
YouTube camera.
Next time we just need to punch in closer so they can at least see what we're talking about.
Here's a second camera.
All right, guys. Have a great rest of your week. All right. How do you end it? I paused it, but I forgot how you end this. Oh, no, we're still live.
It was this shot of Joel for like 30 minutes while you were talking.
At first, I thought he had it reversed. I didn't know he was actually pointing at me.
No, yeah, he just had it right on you the whole time.
I was showing them the bits. We're still live.
Behind the scenes. Get
This
to know
studio is like frozen.
I guess we're gonna stay live.
We'll stay live for a little bit.